Hello, welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Before we start, I'm excited to share that we're hosting Rust Asia Conference 2025 on March 28th in Hong Kong. This is your chance to dive into the world of Rust in Asia and beyond. We've already got Tim McNamara, the author of Rust in Action, as our keynote speaker, and more speakers will be announced soon. Check out all the details at www.rustasiaconf.com. Now back to the episode. Today we have a returning guest, Brenden Matthews, who came out previously to discuss his previous book called Code Like a Pro in Rust, I believe it was. Now you have this new book coming out, so that's why we brought you back on. Maybe just you can give your quick introduction and talk about your books.
Yeah. So just two books, but there were a couple of title changes. So give a bit of background. There was one book and it had one title and then changed the title. And then I also ended up splitting that book into two books. So half, about half that content basically got pulled out of that first book and became a new book. And then that book went through a couple of title changes as well. So title's not going to change now. Book's published, but I guess it made it a bit confusing if you'd bought like the early access copy, then might have been confusing. But yeah, now it's two books. The second book kind of, like I said, came out of the first book. And what happened was that I wrote the first book and it kind of became obvious that there were really two major topics in that book. And it seemed like the sensible thing to do was to split that into a separate book altogether. That also made the whole process take a lot longer because you have to go through, reviews and revisions and so on. And there's a lot of back and forth there and trying to you know, catch all the errors and references and stuff. I think I maybe missed one or two in the first book. So there's at least one error, I think, unfortunately, in print, where I make reference to a content later in the book that got moved to the second book. And so someone kindly pointed that out, I think, in an Amazon review. But, that's life.
Yeah, that must be what it was. It must be the quite a few name changes that happened in between that made me feel like there's so many more that you were writing because I just remember, I get like a daily update about books coming out from Manning just because I subscribe to their mailing list. And I could have sworn I remember seeing your name pop up a couple times with different and I remember it was like different names and I was like, another one? I'm like, this guy must be working full time for these guys if he's got all his books coming out. He must be their main person for Rust.
Yeah, I think there would be like five different titles in total, probably, at least. I don't know.
Yeah, that might have been it. But I do recall the Code Like a Pro. That one was good. It's great. You cover so many topics. I mean, how would you call this new one? So the new one, the new book's name is Idiomatic Rust, right? Which, if you think high level, they sound in the same ballpark. So, where point does what book does this become its own book, and what's going on with that, and why what was the decision?
The idea of the original book was to, I wanted to write a book that would make it easy for people who are like already experienced programmers who want to start using Rust and get productive quickly. And it was just these are the main things that you need to know, like good starting point, without spending a lot of time or detail just in terms of syntax or basic language stuff. So I gloss over a lot of that and I just kind of go into, I think, the sort of the good stuff, right? And so part of that was if you're coming to a new language, you're going to want to know what are the design patterns, idioms, conventions, and so on that you probably want to know about that language that are that kind of information is generally not expressed in your typical language tutorials, right? A lot of the language tutorials are generally focused on syntax and here are the basic structures and standard library things. basic sort of stuff. And so my thinking was like I should really have some content in here about like what are the design patterns that you should know. Like if you're looking at someone else's Rust code from someone who's like an experienced Rust developer, how how would that code be structured? What kind of patterns and idioms and conventions and so on are they using? And so anyway, that became a book on, well, the original title was Rust Design Patterns. And so the idea was to write a book kind of like the I guess original C++ design patterns book, but that title didn't really fit because my book wasn't really a book on design patterns strictly. It was more a book just on like more broad about not just design patterns, but like idioms and so on that you find in Rust. And I try to stick to like basically like the core things that you need to know if you're relatively new to Rust. And I try to put everything in the context of like how it relates to what you might see in other programming languages generally, I guess. I hope it's helpful. Design patterns are like pretty useful in programming, but they're they're not, they shouldn't be treated as a religion, I guess.
Well, there's a reason why they're called design patterns in terms of I'm just trying to say there's more than one of them. So there can't really be necessarily a religion, of course, unless of course you say like, oh, you have to do, all of these things or else it's not a pattern, right? I mean, patterns have to be created. And I think after some time, some patterns are kind of Frankensteins of other patterns and or new things, right?
Yeah. So this is something I try to like communicate quite a bit in the book, and it was actually like a piece of feedback that I received quite a bit throughout writing the book is just like people kind of debating about whether a thing is a pattern or not. Like, oh, that is not a design pattern, or like that's an idiom, and blah blah blah. And so like first of all, like trying to decide like what constitutes a design pattern is tricky, and I kind of propose a definition, at least for the for my book specifically, which I sort of, I guess I sort of like borrow this from maybe from what I've read elsewhere on the internet. But generally, like I would say design patterns relate to like higher level patterns, but like ways of structuring your code that they're basically like code structure and code design related, like repeatable and reusable, and aren't related to like style, I guess would be the right word. So idioms on the other hand are similar thing, but it's like they're more about code style, right? So an example of an idiom would be in Rust, you generally use like a snake case for like variable names, right? And for data structure names like a struct or something, you'd use camel case. Like those would constitute an idiom. But like generally in Rust, you don't have to think too hard about idioms because there are tools that sort of like automate that, like Clippy, or just in terms of like code formatting. Like I'd say like code formatting is kind of in the idiom camp. Like whether you use spaces or tabs or like how many spaces or whatever. I would say that's idiom land. And with Rust, you can just use Rust format to automate that for the most part. And then anything that's like sort of like like a higher level convention or whatever you want to call it above that would go into like design pattern land, I would say. But people still kind of debate what's a pattern, what's not a pattern. So anyway, the book title is not design patterns anymore. So I think Idiomatic Rust is actually a good title because the word idiomatic is pretty clear, I suppose, even if you're discussing like design patterns. But I will say, like you brought up another interesting point about patterns, which is like if you think about languages, like forget programming language, language in general, like the point of language is to communicate, to be understood, right? So like you have an idea and you want to communicate to somebody else, and like programming languages are the same except you're communicating to the computer, right? Or I mean, I guess the compiler or whatever. There might be like layers of abstraction in there, but it's basically like a language to communicate instructions to a computer. And so design patterns are kind of like their own language. They're I mean, they're like another language layer, you could say. And the point of design patterns is to be able to have code that is, well, I mean, it depends on what you're doing, but generally, I think the main advantage is like to be able to have code that is well understood by humans, not so much the computers, right? Like you could you could build a lot of like your own really complicated, convoluted patterns, basically. I mean, you could write all your code in assembly, right? But then when somebody else tries to read your code, they're gonna have a very difficult time understanding what's going on and why things are the way they are. It's kind of like choosing appropriate names for variables, right? Like if you just have some random variable and you name it like X or something, then it's really hard for someone else looking at that code to figure out what it does, like what it means, unless it's like super obvious. But generally, like variable naming is hard because again, it's like its own little mini language, you could say, of like communicating the purpose of things. And design patterns are like another way of doing that. And once you know the patterns, you can like recognize the patterns, and it's relatively easy to understand like what other people's code is doing just by looking at it, or your own code for that matter. I mean, I know I had the problem where like I write code and I forget about it and I go back to it and I don't really understand why I did a thing a certain way. And so at least if you're using like the same patterns and conventions and so on all the time, or most of the time, and they're well understood, then it's really easy to go back to them and quickly get an idea of what's going on, I guess.
There's a lot in there, and you do in the book. I just was skimming through it, and the first part you do talk about, like there's basically three layers, and you were basically touching on them again. You have overall architecture, then within there you have your design patterns, and within there you have your idioms. And I think that's a pretty good way to do it. I mean, the way I think about idioms is more like, yeah, I guess coding style. I think you did mention that. When you sometimes you can. I mean, for me, I just remember when I worked back in the bank, and my manager was a big Java guy, and the way that you case Java, it's usually like, is it Pascal case where I forget what it's called, where the first letter is small and then later on for every letter it's you make it big. It's not, is that Camel or no? It should be Pascal. I think Camel would be for class names.
I think it's Pascal. I guess strictly speaking, camels with the first case lowercase. So yeah, I think you're right.
Either way, like I like usually Java and JavaScript, they write variable names like that. And I remember looking at Python, usually you do snake case for this kind of stuff. And so when I saw the Python script that he wrote, I was like, this looks like a Java guy who wrote this one. The way I see like idiomatic things, idiomatic writing of code, like Rust, etc., is when you look at it, you can tell this guy's a Rust developer rather than this guy is coming from X language or first time programming. You can kind of just see it, right? And so you have a certain way of writing Rust. You like say that I forgot what the operator is called, that question mark operator. When you start to handle like the option, it's not options, it's the result, right?
Well, options or result, it works with both, but yeah.
Or result, okay. Yeah. So like when you start seeing that quite a few times, you start to kind of see, oh yeah, this guy knows what he's doing. Things are kind of making sense. I mean, is that another basically the same that you kind of see is like the coding style, how you write your code, not even into how you structure, right? Just like how you write every line, the variable name, things like that.
Yeah, I mean, I think like the handling the options and results, that's a good example of, I would call that a pattern or design pattern. Well, it's a little tricky. I would say that doesn't count as an idiom. That's not an idiom, but it's definitely a pattern that you'd use. Like I have function or method that returns something, and occasionally it can fail, or it might not return anything. Then you can return a result or an option. Typically, like, you use a result when there's an error case, like you might have an error, and you would use an option when you can have something that doesn't return anything, right? Like the C equivalent would be like returning null or something, which is a terrible thing because, like, null is just zero, and how do you know that zero is invalid? You don't. So, well, I mean, you might not. If you have a pointer and it's zero, that's bad. But yeah, in the case of Rust, like, these concepts, these like features, like the question mark operator and options and results, those are core language features. But how you use them and how you actually apply them in practice is kind of like pattern land, I guess. And even though these things are explained in the Rust documentation, I think it's still a bit of a leap to go from understanding, kind of having a basic understanding of the like the syntax and how they're used, versus how you would practically apply them in real life, I guess. And they're not that complicated, but I think these things are worth thinking about. It's definitely easy to use them wrong, right? Especially like something like result, for example, or option. Like, for example, using a result when you should use an option, or using an option when you should use a result. Or one thing that you sometimes see in Rust, for example, is people using a result and then having like the error case be a value. That's something I've seen, as opposed to an error. And I would consider that an anti-pattern. I don't mention that in the book, but there are like edge cases where that might make sense. But like, I wouldn't do that because I think it's confusing. If someone else looks at that, they're like, why did you put a value in the error? That's confusing. So I think it's important to think about this stuff generally, and a lot of it is not obvious.
That's a pretty good point. I wonder if there's cases where maybe you do want to have, these things changed around to something else. Or, I mean, there probably is, depending upon how you think about your application.
Yeah. Well, I mean, using the error thing as an example, like sometimes you want to return an error, but there's data in the error, right? So an example of this might be, let's say you have a function that you call, and you're passing something into that function by value, right? So like you're moving some piece of data into a function when you call it. And then under normal circumstances, like, let's say if there's no error, you want to return that data as the result, let's say. And so maybe in the error case, you still want to return that piece of data, but you also want to communicate that there was an error. Then you might want to include that data in the result somehow, right? And so the wrong way to do it would be to just like return that data as an error. I think the right way to do it would be to create an error type that you just put that data into, right? So you just have a structure that holds that data, and then you would return it as an error. But I've seen people do the other thing where like they just return the thing as an error, and then I guess it's up to the person calling to sort of interpret what that means or what the error is. And I don't know, maybe it's specified in documentation or whatever, but I don't know. I still think it's non-obvious. It's like, again, it's like if you're using a language, like, if you're speaking English and you're just sort of like making up your own words, like, you can do that, right? There, people are making new words all the time. The young folk or whatever, making up whatever, talking about their riz or whatnot, and that's fine. But if nobody else knows that or like understands that language, then it's going to be challenging for them trying to like follow that. So, like, languages are always evolving, right? Programming languages, design patterns, idioms as a language. If you can like think of those as their own kind of language in the sense that you're like communicating information by using those conventions, then they evolve as well. And generally, like I think I say this in my book, like you shouldn't really be dogmatic about these things. Like you should you should have the assumption that these are going to change over time because they will.
That's a pretty good point. I mean, quite a few things came to my mind when you were discussing that. I was also thinking too, something that people don't often think about is how to actually create a proper library, right? Because you just think, okay, I just add pub to structs, etc. But there's actually more nuance to it too. It's been a while since I remember people talking about this, but like, is it that you cannot easily add traits to certain things? Like, if you wanted to have it so that you can expand your library with new things, because I mean, there may be a time when you're using traits are quite nice, but I believe you cannot just add traits to anything but your own structs. Is that right? Or
It's complicated, but in Rust there are certain like limitations in terms of what you can implement a trait on, and like which what traits you can implement, I suppose. So generally, like if you have a library and it provides a public trait, you can implement that trait for your data structures, right? But if you have the other way around, so you create your own trait and you want to implement it for like another library's data structure, you you can't really do that. It, not exactly. At least you can't make it like public, so that like you couldn't publish a library where you have a trait that you're implementing for like someone else's library. But what you can do is you can like create your own structure that wraps another data structure, and then you can implement that trait on your data structure. And there's an important reason for that, which is that like it gets very complicated in terms of like how to maintain sanity with like your libraries, and basically at like the compiler and linker level. So yeah, Rust doesn't always let you do that. And then it also gets more complicated once you get into like objects, and there are like few rules around what you can and cannot implement traits for. So yeah, generally people will run into this issue where they're like, "Oh, I want to create a trait and I want to implement it for this thing, but the compiler won't let me." And so, of course, there's like a pretty simple pattern for getting around that, but it does. I think if you first when you first run into that, it does feel like a limitation, but it's a pretty sensible limitation. And there are a few patterns that people use in Rust that are often applied to go around this. Like one is literally just creating like any kind of structure that wraps like holds some other thing, right? That's pretty simple. Like make your own struct, uh, make it public, and then someone else can consume that. Like if you're writing a library, you can use tuples, of course, or like tuple struct basically, which is like just a struct with like one thing in it, you could say, one member. And then there's a pattern called the new type pattern is what I'm thinking of. So the new type pattern is a pattern that like one way that you could use to work around this, but the idea of the new type pattern is that you basically have a really simple type that is essentially just like a contains like a single member element, and generally like you use it to like convert to and from different things. So in the case of like external traits, one thing you could do is use the new type pattern just to like essentially like unlock external traits and then convert between your types as needed, or just use like plain old struct, I guess. And like all these things are like based on the same sort of like the same main parts of the language. It's just applying a name to the pattern and saying this is the pattern. So like Now you can just say, I'm using a new type. And then other people see, oh, it's a new type. Okay, I know what that means. That means this is for converting this to something else or just like wrapping another type, basically.
This is another question just popped in my mind is, I mean, Rust does things a little bit differently than most other languages, especially C, C++, where it's supposed to be kind of, you know, somewhat of a replacement. I'm not going to say it is a replacement because that's a whole other thing. But I mean, the idea of traits is quite. I mean, it's basically an interface, and I don't think C, C++ has something similar. Maybe templates is something I've heard of in C++. I don't know how similar they are. I may get myself in trouble because I don't don't know this very well. But these patterns that are emerging, I'm kind of curious about how you can even really name them because Rust is such a new language that the use of traits and some other things, people may not even know a name for it. So how are these things actually getting named and getting explained and talked about? Is there somebody who just writes a blog and that, therefore the name is kind of that?
Yeah, that's a good question. So, as far as I know, C++ does not have like traits or interface, maybe yet, but I can remember hearing there might be like some talk about adding something like that, maybe in like the next, or maybe it's already there in like the bleeding edge. I'm not sure, but it's a good point. I do think there's a section in my book where I try to like define traits and sort of like explain like I'm five sort of way, I guess. And I think the way I describe it is that traits should be thought of as like a way to add a feature to something else, right? So like a good example is like the clone trait, right? So like in Rust, if clone is implemented, it means you can clone an object, right? So you can just call .clone, and that method will return a copy, should be a copy of whatever that thing is, right? And so the clone trait itself is really simple. I think it's just a single method probably, and it's kind of ubiquitous. It's everywhere. It's easy to create, or it's easy to apply to your structure because you can just derive it automatically, which works by like you can use derive if everything, like if you have a struct and everything in your struct implements clone, then you can just derive it because like your implementation for clone is just like clone all the things that are in your structure and then you have a new thing, right? So that's pretty easy. And if you have an object that doesn't implement clone, then when you add clone to it, like you implement clone like that trait, you're basically saying like add this new feature onto my object essentially, or like implement this feature. That's a pretty different idea from like C++ land, right? Where like in C++, if you have some object or a class or whatever, and you want to like add a new feature, let's say, to that, then that involves like adding a new method and implementing that method. But like there's no concept of saying like I have this other class over here and I just want to just basically like inject this single method into it. That doesn't really exist. What you can do is of course like use inheritance, where like you create a class that inherits from another class and it essentially inherits all the behaviors and like features from the other one. But like traits kind of like invert that in a sense. And so it's like you're adding behaviors or features into an object as opposed to creating a new object and then like pulling features of whatever from somewhere else, I guess. That's how I think about it. And yeah, it's definitely a different mental model, I guess. Probably takes some time for getting used to, but I think it's pretty sensible actually once you to it, spend some time working with it.
It's definitely something different. I'm not too sure how you do mocking in C, C++, but for sure I can see traits is definitely a way that you can do mocking. People do mocking with traits because you can just say, okay, like here's a database and has a read and write all these things, and I could just create a mock instance that implements this interface of the using the trait and say, okay, now I can mock everything out. Like to me, that's definitely a powerful feature of it.
Yeah, basically like if you start to get into trait based programming, I guess, in Rust, then your like interface or whatever just becomes a trait. So if you're writing a library or something, or just like you have a function or a method or something, then instead of saying like to call this method, you have to pass this type of thing in. Instead of that, you say like to call this method, your the thing that you pass in has to implement this feature or provide this trait, right? For example, like using the clone example, like let's say, I don't know, I have something that is going to clone an object or whatever. Like I all I have to do is write a method that says this takes a type, like any type, and all it needs to do is provide the clone trait, and that would be like a trait bound. And so, someone downstream like calling that method, all they have to do is make sure that that thing implements the clone trait, and then you can call it. And that's like a it's a pretty simple concept. Of course, when you like get into like library building, then now what you do is you write traits, and traits are like, you know like to call this method or whatever, like anything that implements some feature. I don't know. It's if you've got like a database or something. Let's say like you have some, I don't know. Pretend you're like building like an ORM or something, like an some like object mapping thing on top of a database or something, and you want it to be able to work with like different databases, then you might have a trait to I'm like really simplifying, but for the sake of example, like you might have a trait that represents like a database. Like here is a database connection, and like you can pass me any kind of database connection provided it's implementing a database connection. In practice, database connection is a pretty complicated thing, but if we could pretend it could be represented by like a simple single trait, then um, you could specify it that way, I guess.
That's the way I do use it when I do want to start mocking things out. And so, but yeah, obviously there's much more. I like the way that you talk about it's like a way of unlocking features. I never even thought about that, but that's a really good point. Especially if if you have some kind of special data type and then you want to be able to use it across threads. You have to add sync, I think it's called, and some other traits. It makes things really easy. And then once you add those, you're like, great, this is easily usable. Across threads. I don't need to worry about anything because you actually unlock that ability of this, data structure.
Yeah. So yeah, sync and send are two like special magic traits, if you will, where generally they're automatically like provided. And the way that works is like the compiler will just look and see like, okay, does everything, like if you have a structure, does everything within that structure implement these traits? If yes, then it's just automatically implemented. If not, then it's not. And so if you have like a structure or something and you want to make it send or sync, then all you have to do is just make sure everything within that provides that. And the way that you do that, if they don't, is to just like put things within something that like provides those traits, right? Like wrap it in like a like some type of lock, like a mutex or whatever, and then it'll like exist. But yeah, it's I think what once you get it, like it's a pretty good model, I would say, for thinking about these things.
One thing I don't really see a lot of people using pattern matching. Usually there is, but not as much as I've seen some other languages. I mean, is that a form of idiomatic Rust?
I think Rust pattern matching is a bit different from like what you might see in other languages, and it's very useful, but I like it, but I would say it is in some ways it's like kind of a little bit underwhelming when you compare it to how it works in certain other languages. Like for example, in Erlang or Elixir, it has like a really powerful pattern matching system. And one thing you can do in like Erlang or Elixir is you can, if you have like a structure, some kind of like nested structure with data in it, you can like match deeply nested structures on like specific values within that structure, and that's super powerful because it lets you like kind of pull data out or like essentially like filter data. So you could, if you imagine like you've got a function and you're just like calling it with any generic data, and you essentially just want to like pull specific values out, then that's like really easy to do. Now in Rust, you can sort of do that, but because of the way that like Rust is typed, it's hard. It's not as expressive, I guess. And so you can, like in terms of structures, you can match on like individual members, or like you can pull things out of tuples and stuff. But you can only do it with like specific types, and it's possible to match on like values, right? So like for example, if you have an integer and it's like I only want to match if the value of the integer is 5 or is like within a range or something. You can do that in Rust, but what you can't do is say like if I have a string, I want to do this, or if I have an integer, I want to do that. You can't really do that. You have to have like you can only match on one type, which limits the expression. No, there's a way around that. You can use like an enum, right? So like an enum can contain different like one of different types of things, and then you can match separately on that. But it's like another layer of indirection, I guess, that makes pattern matching like a little less. It's like it's very useful, but it's like it's slightly clunkier than I'd like. But like that's just kind of the nature of it, the nature of the beast. Given that this is like a strongly typed language, I don't think there's like it's not something where like they could, you can go back to the drawing board and make it work better. It's just like comparing Rust to like Erlang or Elixir is unfair because those are like dynamically typed languages, and so you know there's no way you could have like the same level that level of expression. But like pattern matching is still great. The only problem is just like sometimes you can get like really like deeply nested or like really complicated pattern matches, and I think generally the solution to that is to just like not do that. And by not do that, I just mean like if your matching is getting like really complicated or like really nested, like just like start pulling things out, right? Like pull those complicated bits out into other functions or methods and then call them within it. And I guess that's just sort of like basic code hygiene stuff generally. Still a huge improvement though. And I'd say like in practice, I think most of the time, at least when I use pattern matching, is it's usually just like 2 or 3 matches, right? So two would be like if I have like an option or a result, then your matches are like success, failure, or well, there's no third case in that case, but like usually it's just like 1 or 2, and then you always have like a else match case, like what to do when none of the other matches match. I guess you would use it with enums a lot, right? Where you have like multiple options within your enum, and you essentially just want to like go through each of the possible options and then perform some action or whatever. I like it. It's better than like if statements generally.
When I heard that Russ had pattern matching, I do a lot of Elixir still day in, day out, and so I was like, "This is great," I love pattern matching, and I was like, "Oh, this is
Yeah.
underwhelming," to say the least, when you come from those kind of languages. There's some really cool stuff you can do, but yeah, with those Erlang Elixir, those being more dynamic, you can definitely do, like you said, more stuff. But yeah, it definitely does kind of make things more interesting rather than just saying if else, because you can kind of get yourself out of there, and then they have a form of guard clause where they say, I don't remember what the keyword is. Is it also when, or is there something else?
Yeah, you can have guards. You can basically just have an if statement. So like match on this thing if this condition is true. And it's just like, it's just an ordinary if statement. So you can put anything in there.
It does help a lot because there's some things you want to express. So, but still, nonetheless, I wish there was a way that you could pattern match at the function head level. It does kind of dry up some code.
Yeah, the way that works, yeah, like Elixir, where you can essentially have the same function signature with the match in the function. I mean, that's basically just like syntax sugar, but it's really nice. It's a very nice way of sort of like flattening the code out, you could say. It would be cool if Rust had that. I don't think that that's something Rust would have though, because it doesn't. The reason it wouldn't, I don't think that would happen, or maybe I mean I don't know, maybe someday. But the reason it doesn't make sense is just that Rust is sort of intended to be somewhat C compatible in a way, right? And uh, that's not a very C like thing, right? Like functions don't really work like that in C. But I don't know, who knows? Maybe Rust will like one day add something like that.
Yeah. I mean, I could see that happening because I mean the way that Elixir does it in Erlang is it is like you said, some kind of sugar. I heard it's basically implemented with a bunch of case statements. So I mean, under the hood, it may just, generate a bunch of functions since we already do like I mean, I think it's possible to do because we already do like the generics and we kind of take a look to see where which forms are being created. So I can see definitely probably is a way to do that. But yeah, I think that a typical Rust developer, this wouldn't be idiomatic Rust at this point right now. People would be like, what is this? It would definitely be something that would just, I don't know, it would just blow your mind. It blew my mind the first few times I ran into it. But then, yeah, I think it would be just such a shock for so many people. I don't know about how you feel.
I mean, I think it would be nice, but like I said, I think the purists would be like, well, you can't do that because you're secretly generating multiple functions, and then how's that going to work in my world? But I don't know. I mean, you can write macros that would essentially do the same thing, but that's like kind of a little ugly, I would say. Making a core language feature is tricky. And realistically, like in Rust, if we're talking about like C compatibility, the truth is like if you're using Rust and you want to be able to like call Rust functions from C anyway, you're gonna have to like take extra steps to like use the C compatible types and so on and so forth. Anyway, so like, does it really matter? I don't know. Probably not. It would be a nice feature though.
What else I thought was pretty interesting is that you started talking about coroutines, which is pretty interesting. I mean, because coroutines, like you mentioned in the book, they're upcoming, they're up and coming. I think they're about to be released sometime soon. I'm not sure where they are on the stage, but I do I did hear of a couple people talking about them. The way coroutines work in Rust, I don't know if everybody knows about them. It's like they're not called are they called cooperative? There's two types of ways to do it. There's like one where it's called yeah, I don't remember what it's called, but there's one where you tell you that thing, that thread or whatever you want to call it, that thread that's called that thread of execution tells the scheduler when it's like surrendering power, right? Which is it's just you have to kind of trust it, right? And that's what a coroutine is. It has to tell it has to surrender itself. So that part's quite tricky because I mean you always want to just keep going to a certain extent, but people use coroutines in a way that's similar to what I would say like a Python generator. We have this yield keyword.
Yeah, that's right. So, well, I think there was like some debate about what to call these, right? Generators or coroutines. That's one thing. But I guess it's important to maybe understand why we might want this and to get to like the short version of the answer to that. It comes down to the fact that like building concurrent multi-threaded software is very tricky. Even like for example, like with like async Rust and Tokyo and so on, it's still like a lot of people like for example aren't super happy about async Rust because it's still very difficult to do a lot of things. And the reason it's very difficult is because it's always going to be difficult doing any kind of like multi-threaded concurrent anything because you've always got a problem of like race conditions sharing data across threads and so on. And that that problem inherently makes it tricky and makes it really hard to like implement certain features. So like coroutines or generators essentially give you another way to provide concurrency without necessarily having to worry about the details of like the like multi-threading, like the race condition aspect, I guess. And arguably like the coroutine generator model is probably much easier to think about most of the time. And so, that's cool. But it's not there yet. And yeah, I mean if you use languages like Go, for example, the Go routines, or anything else that has like something similar to that, I'm trying to think of good examples, then yeah, it's like it just frees your brain up from having to worry about more stuff. Like if you never have to worry about data, like race conditions and whatever, then it's a lot less challenging to do many things, I guess. So I think that's like the main excitement. And they also like enable like I think certain patterns that are a bit tricky to do without them, which I think I mentioned this in the book. On, I'm just scanning real quickly here. Yeah, Python's generators are probably I think like a lot of people are probably familiar with Python and its generators. One thing is like this is a good example actually, creating like having an iterator over data, like a stream of data, is a surprisingly tricky thing to do. For example, like in async Rust. So like why is that? Well, the answer to why is like it's just difficult when you get into the details. And so like you can't, for example, in Rust you can't, if you have like in something that's like returning a stream of like async whatever, you can't use like the iter and then do like an await in a loop. You can't use like map, filter, any of those things with something async. You have to, the only way to like iterate in Rust, the only way to iterate with async is to use a for loop. So you have to like write for, this and that, and then put your await within the for loop. That will work. And so coroutines would like unlock that, uh, which is like a fairly specific example. And so, that's an example of a thing that people who use async Rust would find out really quickly, and they're like, wait a minute, why can't I just do this? And the answer to why is like, if you've got something that's returning a stream of data asynchronously, then like answering questions like, okay, well, what order do I do things in, gets really complicated, right? And I don't know, that's a pretty big discussion on its own, I would say.
I didn't really think too much about having. I mean, I knew coroutine looked like a generator, but I never really thought of like, oh, basically, it probably is a generator. It could be infinite. I think when I read about it, yeah, that was what they were talking about. But that's a good point. I mean, all these languages always kind of implement the same or similar things, and they have different names. Like since we talked about Elixir Erlang, a list in Erlang versus a list in Python, they're like two different things, right? As opposed to, an array in PHP is, similar to like, it could be similar to, say, a dictionary in Python. It's talking about Python anyways. They're key value stores. It's an associative array, right? Things are done similar and different and same, in these different languages. It gets quite complicated to figure out like, okay, what's what, you know, whenever I get to a new programming language, I gotta start to figure out, well, how do I do this kind of thing in this language? And you start kind of learning your way around it. And I guess that's basically what idiomatic Rust and code like a pro in Rust is basically doing, is saying, okay, you're new to the language, you want to learn it, great, it's good, great benefits. This is how you do it, right? That's basically how I look at your two books. Is that how you would say?
Right. that's the idea. It's like, yeah, if you're learning a new language, you've got to learn the new grammar and definitions, right? In any language, like a lot of language, I'm talking like spoken languages, generally, like for example, they share words, right? Like in English we use words from, I don't know, French and whatever else, but even though like they borrow, there's like slightly different meanings, I guess, for a lot of things, right? Like all these languages are kind of like derived from each other in different ways, but everything's a little different in different contexts. And yeah, you need to like understand what those differences are.
but basically enough to kind of get my way around. So I think, you're especially the second book, the one that we're talking about today, the Idiomatic Rust, is something that helps a lot. The Code Like a Pro and Rust too was also great too. I remember reading that. I was like, this is exactly the book I was looking for when I was really first starting getting into Rust, because you talk about, a lot of different things. I think it's been a while since I looked at it, but I just remember reading. I think you do touch on, oh man, like Clippy and a couple other kind of things that people should know, and you do know once you've been doing this for a while. But stuff that's like, because that's really what we really need for in the community is stuff like, okay, you're new to Rust. This is what you need to know. You got to know Clippy. You got to know basically Tokyo. Obviously, it's not the only things out there, but if you're just starting off, there's too many. There's quite a few choices. Better just choose these for now, unless you have a good reason. That kind of like starter guide for beginners is super helpful to have.
Right. I think a lot of the like official documentation or like the Rust book, that stuff sort of doesn't doesn't really cover. It's like, here's how you write Rust, except it doesn't explain like, okay, but like where, like what do I use? What do I use? Like do I use VS Code and like blah blah blah? And, doesn't really go into that if you're like really starting from zero. So yeah, I try to cover just go, just go do this, start here, and this will like get you going, right? Make sure you have Rust Analyzer, and it'll make your life 100 times easier. Stuff like that. I don't know. Maybe Rust Analyzer is mentioned in the official documentation now. I'm not sure, but it's like it's like one of those things that's like really like makes a lot of sense and it should be mentioned, but I'm not even sure if it is anywhere.
Well, I think it's hard to mention, right? Because if you're, let's just say you're talking about the official kind of Rust docs, the Rust book. I mean, those are kind of like, the official stuff. So if they start picking frameworks or languages or editors, that can be a little bit tricky as opposed to saying, okay, this stuff is standard. Like, if you want to use a string, we have a string.
I mean, yeah. It would be one thing if this was like a company that was like endorsing another company's products or something, but like that's not what it is. These are just like open source tools, and they're the best tools. And yeah, to really be productive with Rust, like you should just use these tools. And I don't know, maybe it doesn't belong like in the right out in front in like the documentation, but like they could at least maybe point a little bit to be like, here's some good place to get started. Like this is what we suggest, or like this is what some people use, maybe. And I don't know, maybe the documentation says that now. I'm not sure, but I know for me, like learning Rust, there I didn't really find any guides or information on that stuff, and I wasn't sure why, so I had to figure it out the hard way.
That's why I think, your books are definitely great for people who are starting off, because you came from that pain point and you're able to kind of say, okay, a lot of info out there. Let me just distill what I learned, which is fine. Even if it's not, I mean, what is correct? That's what I was gonna say. Like maybe if it's not correct, but to be honest, what's correct? As long as it works, I mean, and no, nothing bad's happening. I would say that's kind of correct enough. Even when you talk about languages, with me living in Hong Kong, like I say Chinese wrong all the time, but if you think about it, I don't think most of us speak like one day. I don't think all of us speak 100% grammatically correct our own native language. Like, and actually, but I mean, like, even if you do, people would be like, something's weird about this person. Like, they speak very weird because you're just so used to, their own way, right?
It's not really about the correctness, it's more about like, are you communicating effectively? If you can do that, then you're succeeding, really.
That's a good point too, and I saw heard that's what I remember hearing about too. Like if people understand you, and then you're basically doing correct, even if it's not grammatically correct. I think we're coming up to the end of our time, and we can keep going on and on about all this kind of stuff. Do you have any kind of last words for us before we sign off?
I like Rust a lot. It's always really fun to work with Rust. Yeah, if people get value out of my books, that's great. I enjoyed writing them. It took a while, longer than I thought it would, but yeah, I hope somebody finds it useful.
Definitely. I just remember Code Like a Pro and Rust many years ago. I remember just reading it on my phone while I was doing something, and I was like, "This is perfect." And this book also seems like a great companion to the other. So yeah, again, thanks for coming on, and maybe we'll have you again back on again in the future for the next book. I feel like you're going to be writing more, but maybe I'm wrong.
Maybe I don't know. It's a lot harder writing a book than I thought it would be. I mean, writing documentation or like putting on the internet, I think that's a lot easier than trying to like do a print book. That's harder.
Well, I think writing books is kind of like having kids. A lot of people especially don't like all the stuff with it, but then at the end they're like, actually, it wasn't too bad. I kind of enjoyed the process,
Yeah,
and then repeat, why did I do this again?
yeah, probably sounds about right.
Again, thanks for coming on. It's good to see you again.
All right, thank you.